Hello, everyone. Thank you for this opportunity to present this talk today. I am Rima Chaudhuri, and I lead the data science team and data science efforts at Finder in Australia. So, my talk today is about identifying and leveraging on money personalities using machine learning in personal finance management. So before I jump in, a little bit about Finder. So Finder is primarily a comparison website for financial products. So basically, we host a lot of partners who are providers of financial products on our website for customers to essentially users, which is anybody on the internet, to come find the best option for them when they're looking to compare home insurance or home loans, personal loans, credit cards, anything that's basically purchasable and in the financial sort of domain. We also have an app platform, which is primarily geared towards a personal finance management tool, but it also allows comparison just like the website. At this point, we're about 375 crew worldwide, with presence in UK and US outside of Australia. So, what do we do and why do we do that at Finder? The mission statement is to help customers make better financial decisions. So, as I mentioned, we host comparisons of different products, and what we try to do is use data and data science to really enable this mission, to be able to bring out the best deals that's most relevant to the user, whereby you could address this in different ways of personalization, as well as customer segmentation, etc. Right now, we have about 3 million users worldwide every month, and this is a rapidly growing number. So you can imagine we have a lot of data to work with, especially in the website. Today's talk, we will chat mainly about the app and the different ways that machine learning can help in that respect. So, right. So what are we going to learn today? Main thing that we're going to start with is, well, what are money personalities? What do we mean by that? Then we're going to move to looking at one of the ways, I guess, to identify these kind of money personalities. Once we identify these money personalities, we will look at a way to leverage on them to serve the customers more relevant information as well as drive revenue for Finder. And all of this we will try and address using machine learning algorithms that we'll dig a little deeper into. So, to answer the first question, well, what are money personalities? Based on who you are, we can we say anything about your spending habits, or vice versa? That is, based on your spending habits, can we say who you are? So it's essentially trying to draw lines between different sets of data to see, can we identify what kind of person you are. For example, if someone is affluent and lives in a certain area, has is kind of retired, their behavior in making purchases is probably quite different from somebody who's a graduate. so so can we then identify these kind of personalities and then cater to them accordingly? So the usual money personalities, depends on which source you look at, include investors, savers, the big spenders, debtors, shoppers. So what we wanted to do at Finder is to see, well, can we identify users with distinct spending habits based on who they are, and can we define those for that's relevant to us? So it allows us to kind of deviate from the generic definitions and make them a bit more relevant to the product groups that we are interested in, or the product categories, and that we cater to. Right. So money personalities is nothing but trying to figure out, people's spending behavior based on who they are, and who they are can be defined with different signals. So, what data types were available for Finder app members? Well, the main things we have are transactional, behavioral, that is the user history, demographics, and financial. In the talk for today, we have not used behavioral data in this exercise, but it could very well be folded in. So the main things that we've used is transactional, demographics, and financial. Now, what is the information flow here? So I obviously have to distill down and make everything very generic for the purposes of IP. But I hope it's still quite meaningful for you to know that, well, most of the transactional data, we are able to figure out the purchase power of people. Whereas with the demographics and financial status information that we have on the users, we're able to figure out their borrowing power. So now when you combine somebody's borrowing power and somebody's purchase power, you get a decent, overall picture of that person's profile and their money personalities. And this is the kind of information merger that we're trying to do in this analysis to identify those. So as going back here again, in the transactional data, I said we want to look at the purchase power, right? So transactional data, for you to be able to really understand somebody's spending, you really need to accurately identify what were the merchants or the categories that they were spending on, for you to kind of create a profile on those. So this led us to the first model, which was the merchant prediction model based on the transactional data. Now, why did we have to do that? So we do have a provider that gives us the transactional information, but there were a lot of cons to it. For example, a large proportion of the data had missing value, meaning the merchant names could not be predicted. So we took it upon ourselves to kind of not throw away those 40%, but to develop our own algorithm and see if we can get somewhere. So the challenge was obviously it's very noisy text, unstructured data, which I wish upon no one to process. But anyway, so we did a few things to it to handle the issue. First was for the algorithm that we wanted to use, which was natural language processing technique of named entity recognition. We had to do some manual labeling of the transaction data for the model to learn from, in terms of rights. So which what is the merchant in this entire string of text, which is not a sentence. So the manual labeling process was probably one of the most time-consuming bits. So we did do some outsourcing, and then also in-house we did like manual human labeling. Beyond that, what we did is we downloaded some publicly available data sets, for example, from the Australian Business Registration, as well as the Australian Securities and Investment Commission. And they have a list of businesses. So, we downloaded those databases to then do a fuzzy match to see if we are able to automatically kind of label the merchants. So following that and a few text cleanup steps, we landed up, building a model using named entity recognition, whereby it pretty much learned the indices of where the merchant lies and accordingly predicts for you for unseen data. So with this, we landed up getting a coverage of about like 90% more. So out of the 40%, we basically only missed 10%, that there was no way for us to tell who the merchant was. But for the remaining, we were pretty good. And then when we did a sort of evaluation, we saw that the merchants that it did predict were was standing at a 94% accuracy. So in the test set, obviously we had it labeled, so we could tell whether we've got the right merchant or it's picked up some other word. So it was not a bad place to start. So once we had the merchant names, now life was a bit easier. We could go to the category prediction. So to figure out like what are the categories of expenditure. So we did get this from the provider as well, but again, the quality was quite poor, and the groups that they predicted the categories were not really relevant for us at Finder. So again, we decided to create our own. So the challenge was the same. It was noisy test description data where a lot of the words are cut off, and it's quite messy. So we had to go through again the manual labeling process of what the categories were. We had to do some text cleanup. So we did use the description, and we this time looked at a multi-class classification model with some class weights, because there was a lot of obviously class imbalance in the data based on what the categories of expenditures were. So you could oversample or to balance, or we landed up using class weights. The results for us on the whole dot set was about 0.92 was the F1 score, which was the most appropriate metric because of the imbalance in the data. So again, not a too bad a place to get started, seeing a decent balance between precision and recall. So now that we did this, so what does this really mean for us? So we have a much more reliable merchant and category prediction on the user's transaction. So what does that let us do? It gives us the ability to calculate the spending of the users per category a bit more accurately, which is quite important when you're trying to serve these to the users. So now the question is, right, so now can the transaction data, where we did this, sort of summarization really in terms of what categories they belong to, be more meaningfully linked to the other dimension of information that we have available? So as a POC, as a proof of concept, we kind of did some multidimensional clustering using the other sources of data that we had, which was the demographic and the financial status signals, to now see, can we do some clustering? So what did we do? It was the same set of users, the app users. We dropped all the non-numeric features. For the numeric ones where there was missing value, we did an imputation using mean. And we looked at a few different algorithms for the clustering to see. It was a large set to see, what gives us a decent sort of result. We landed up, figuring out through some iterative processes in what was the subset of features to use. And then we used k-means, and the evaluation was done with 3 different measures, the silhouette, the Kalinsky Harbaz, and the David Bolton score. So they kind of are distant place. So whatever formation of clusters, the quality was kind of evaluated by these 3, and whatever had the best sort of scores as a consensus between the 3 metrics, we kind of used those. So iterative search, as I say, among the demographic and the financial features that we had on the users, helped us find the 7 optimal clusters using 3 different features that we deemed to be giving us the most quality of clusters. So, okay, so now we have 7 clusters based on demographic and financial status of the users. And now what should we do? Let's have a greater, deeper look at that. So for IP reasons, I cannot disclose what those features were, but let's call them feature 1, 2, and 3. And as you can see, the distribution of those features across the 7 clusters. The x-axis are telling us which cluster they belong to, and the distribution of each of those features. So as you can tell, like group 5 and group 7 are perhaps the most different, because all 3 are quite low for 5, whereas they're quite high for 7. And we've given them like some names, like 0, we call them workforce, and like high flyers. So the one that's number 5 are like starters and reckless. So these are like little nicknames we've given the clusters. But ideally what you see is that, in the 7 clusters, you see a various sort of different pattern of distribution of those 3 features. Right. So now that we have those clusters, and on the other side with the transactional data, we have the categories that they spend on for the same users, can we overlay them and see some patterns? So what we do is we look at the spending across various categories, across the 7 clusters. And as you can see, some common things like, like everyday living, like gas and electricity, telecommunication, etc. So marrying different types of data, gives us some meaningful trends. So we dig a little deeper in one of the groups and we see, okay, so in terms of expenditure and credit cards, there are 3 groups where the people don't seem to basically spend that much on credit cards. If you look at what those clusters are, it does seem meaningful. Unfortunately, without the knowing the meaning of the features, it might not be that intuitive. But you see that the orange is kind of low in all of them, where it seems like there's low spend. So there's some kind of sort of pattern that emerges. Further, what we can do is we can even dig deeper into the credit card categories that are perhaps overrepresented in each of these clusters. So what we see here is that from cluster 0 to and number 7, we have about 7 different categories as well. And what you see is, for example, cluster 2 and 4, which is the green one and the purple one, seem to have a really good preference for product type number 3, as they are like the top ones here. Whereas the cluster 0, they have a high preference for type 5 and 7. So the cluster 0 is the orange one. So they're like one of the higher ones there. So anyway, so you basically figure out, as in, right, so these group of people not only have a certain spending pattern, but they also prefer some products versus others, which is a lot more granular. So using these personas, now we can improve the customer service experience and also the marketing efforts. So we can obtain cohort-based insights, which could be used in targeting users for marketing campaigns. Based on this, we can also recommend different types of products that might be relevant to certain groups of users and not others, because we saw they have preference for something versus some other groups. So many campaigns, I think, can be started by mining this information to increase engagement. Right. So that is kind of one set of work. The What we realized after this is that, well, we're beginning to see some, good signal at the product level. What else can we do? So to fully leverage on this information, what we ended up doing is we wanted to figure out which users would have a high probability of redirect on some of the products given their demographic information. So we developed a classifier which predicts the likelihood of specific, cards redirects based on who they are. So it's primarily a multi-label classification algorithm to predict the product categories as well as the names of the redirects of the products that might be associated with people with particular traits that comes from a combination of all the data that you just saw. So we used a top-end classifier where we have built 2 of them, which was layered. The first one figured out the product category, and then based on the categories that were relevant for the users, we predicted the products within those categories that had a high probability of redirect. So this exercise, you'll see, achieved a relevance of 54%, which was a lift of about 4% from if we were to just recommend the most popular products among groups of people. We would have gotten a 51% sort of redirect accuracy based on test set. So there's obviously a lot of external factors that's at play here, since we are only with most popular products, getting to that number. But at least the encouraging bit was that we were able to get, roughly for 3% uplift from, what we saw there. This is yet to be tested, obviously, through A/B testing to see, what impact it actually has in the wild. The baseline of like just giving, any suggestion to a user without even looking at the most popular was at a relevance of 8%. So clearly there is some meaning behind the signal that is giving us the bump to go from even 8 to, 51%. So the relevance metric that we were using here was precision at K. So we were looking at, the top 5 suggestions and seeing in the test set, as in how many of them were actually redirected on from historical data. So this was another way that we could use ML to further sort of leverage on the data that we had and the insights that we could get. So how can all this information be used? As I touched upon this earlier, the main mission of Finder is to really help users make the best financial decision. So for which doing all this work helps us again surface the most relevant product for the kind of person that you might be as a Finder user. And if you really prefer product A and that's what you like, there's no point for me to offer you something that's completely different. So for me to be able to know that really helps in the efficiency. So improving customer experience by surfacing more relevant products is kind of the umbrella term. And then some suggestions we had from that, like to take action on, to actually gauge the impact. We can also have suggestions to match the customer's financial goals if it's available, again to make it more efficient for them to meet their intent. So, and customer segmentation, which was the first bit of environment need personalities, obviously allows us to do a lot of targeted marketing efforts. So that kind of brings me to the end of the talk. I'd like to give my acknowledgements to a few people, which is the data science team at Finder for doing parts of the work that I showed today, actually all of it, and then the data engineers at Finder for allowing us to get the data in a decent format for us to be able to do these analysis. The Chief Data Officer for her support in doing all of this work, and Finder in general. So with that, I would like to also thank the organizers of Data Science Salon for this opportunity. Thank you.